Welcome to qnawire.
So in this problem, we are given that a polystyrene has been placed in between the parallel plate capacitors, and we are given information about the dielectric constant of the polystyrene. So for polystyrene, the dielectric constant K is given to be 2.6, and the dielectric strength of the polystyrene is given to be 2 times 10 raised to 7 volt per meter. So this is the dielectric strength for the polystyrene. Let's call this as capital D. So this is given to us. So we have a parallel plate capacitor in between which, instead of air, now we have a dielectric material, which is polystyrene. And in the first part of the problem, we need to find the electric field between the plates. So the electric field between the plates is given to be 80% of the dielectric strength. So the electric field in between the plates is 80% of the dielectric strength. So 80%, that means it's 0.8 of the dielectric strength. So it's going to be 0.8 times D. And so we need to find the energy density of the stored energy when the electric field is 80% of the dielectric strength. So for the first part, since we are required to find the energy density, and as we already know, the energy density, small u, is given by half times epsilon naught times E square. So that's the formula for the energy density. Now we already know the value for epsilon naught, and the electric field is given to be 80% of the dielectric strength. That is, it is equal to 0.8 times the dielectric strength. So if I substitute the values, so I have half times the value of epsilon naught, which is 8.85 times 10 raised to negative 12. This is the value for the epsilon naught times. So now the electric field is 0.8 times the dielectric strength. So I'm going to write it here like this. So I have 0.8 times the dielectric strength, and the dielectric strength is given to be twice 10 raised to negative 7, 2 times 10 raised to 7. So not negative 7, it's 10 raised to 7 and whole square. And if you calculate the value, the energy density will come out to be 1133. So the energy density comes out to be 1133. Since it's energy density, it's joule per meter cube. So this is the value of the energy density which we get. This is the answer for the first part of the problem. So energy density is 1133 joule per meter cube. Now moving to the second part of the problem. So in the second part, we are being asked that when the capacitor is connected to a battery with a voltage of 500 volt. So now this parallel plate capacitor in which we have polyester as a dielectric material is connected to a battery which is supplying a voltage of 500 volts. And in this condition, the electric field is given to be 80% of the dielectric strength. So again, we have the electric field to be 80% of the dielectric strength. So it's 0.8 times D, where D is the dielectric strength, which we have defined earlier. Now with this condition, we need to find the area of each plate if the capacitor stores 0.2 millijoule of energy under this condition. So let's see the capital U the energy stored by the capacitor is 0.2 millijoules. 0.2 millijoules. And with these conditions, we need to find area of each plate of the capacitor. So finding this, let us consider the equation of the electric field inside the capacitor. So inside the capacitor, the electric field E is given as, so E equals capital Q divided by epsilon naught A. So this is the equation of electric field inside the capacitor. And it comes from, so electric field E is given by E equals V by D, electric potential, times D. And we know that V equals, for the capacitors, we know that Q equals to Vc. So from this true formula, we derive that the electric field indeed is given by capital Q divided by epsilon naught A. So this is the formula for electric field in between the parallel plates. Now the unknown quantity is capital A here. So we need to find A. And what we are given is that the energy stored in the capacitor is 0.2 millijoules. But we know the energy stored in the capacitor as half QV. So from this, we can find the charge on each capacitor, which is 2 capital U divided by V. So we know the energy stored in the capacitor, it is given to us 0.2 millijoules. So it's 0.2 times 10 raised to negative 3 joules divided by the voltage, which is 500 volts here. And if we calculate this value, the value comes out to be 8 times 10 raised to negative 7. I'm sorry, 10 raised to negative 7 coulomb. So this is the value of the charge on each capacitor. And once we have information about this charge, so using this information that capital E equals capital Q over epsilon naught A, we can easily write. So since capital E equals capital Q divided by epsilon naught A, we can easily write, since I need to find the area of each plate, so capital A, which is the area of each plate, equals capital Q divided by epsilon naught times E. And if I try to find the values, so capital Q we have already calculated, which is 8 times 10 raised to negative 7. It's the value of the charge on each capacitor divided by epsilon naught. So the value of epsilon naught is 8.85 8.85 times 10 raised to negative 12, and E, so E is so for this condition E is 0.8 times the dielectric strength, 0.8 times the dielectric strength, which is 2 times 10 raised to 7 volt per meter. And if you calculate this, the area of each plate comes out to be around 5.65 times 10 raised to negative 3 meters square. So this is the area of each plate. This is our final answer. With this, we finished the problem, and thank you.